Hello, everybody. Welcome back. Last week of presentations this week. The other parts of your technology evaluation are due this week, assuming you're watching this in kind of real time. So make sure you have those done. Your presentation summaries, again, just enough to convince me really that you were paying attention and actually watched these things. Those are due whenever, sometime. Yeah, so don't forget those things. And then I guess attention kind of turns to the project after this. So let's say the first videos, as with the other weeks, I'll do 4 videos and then a break, and then 3 more.
Hello, welcome to our presentation on Ruby on Rails. Today we will explain what it is and the many aspects that make it useful. So first, what is Ruby on Rails, or Rails for short? Ruby on Rails is an open source server-side web application framework that is built on top of the Ruby programming language. Ruby on Rails has full stack capabilities and is used to develop web applications such as Airbnb, GitHub, and Shopify. Ruby on Rails was first released in August of 2004 by David Heinemeier Hansson, or DHH as many people call him, and follows software patterns such as Model View Controller, Convention over Configuration, and Don't Repeat Yourself. Later, we will go into more depth in how Rails incorporates these patterns in their framework. So what makes Ruby on Rails useful? Well, one of the benefits of Rails is that development time is very fast. Ruby on Rails comes with many pre-installed features and structures in a newly generated Rails application. It provides the default structure for web servers, web pages, databases, in order to get your application quickly set up for development. Rails values convention over configuration, meaning that developers write less code by following the specific convention, but developers still retain the flexibility to customize. Like many frameworks, Ruby also follows MVC pattern, which produces consistent, reliable, and reusable code. Another useful feature is Ruby Gems, a package manager that allows for easy installation of software libraries and packages. Overall, Ruby on Rails is very fast to develop, flexible, and cost-effective. It is also considered simple to learn and easy to use by many developers. As introduced earlier, Ruby on Rails uses the MVC pattern. MVC is a pattern for the architecture of the software, which separates the application into 3 parts: model, view, and controller. In Rails, the model is a Ruby class that usually handles the database interactions of the application. The view indicates all the parts of the user interface logic that is shown to the users. The views are also written in an embedded Ruby template file that allows placing Ruby code within HTML. This allows you to add instance variables, loops, conditions, and more to your web pages to make them dynamic. The controller is then responsible for connecting the model and view together. When the user from the browser sends the request to the controller takes the required data out of the model, passes the corresponding data to the view, then the view is displayed to the browser and shown to the user. Rails has a powerful command line functionality where features and basic functionality can set up projects quickly with minimal code. These commands, like Rails new or Rails generate, will provide the building blocks and necessary structure for your application, which can be further expanded and built upon. Here's a list of some of the commands that we found useful when it comes to creating new projects, MVC-related files, and database operations.
As we discussed, a model represents the data of the application and the rules to manipulate that data. Therefore, in Rails, models are used to manage how an application interacts with a database table. Typically, there is one table in the database that corresponds to a model in the application. Ruby on Rails offer built-in support for SQLite, which is a serverless database stored on disk. This is the default database configuration. However, you can change this configuration from the database.yml file to the database management software of your choice. Migrations are Ruby classes designed to make it simple to create and change database tables. It uses rake or Rails commands to run migrations. Active Record is a component that Rails provides free for creating web applications, which is the base for the models in a Rails application. Active Record provides database independence, basic CRUD, which are the create, read, update, and delete operations, validation, and more. Routing in Rails manages the path for all the possible HTTP requests within the application and interacts with the corresponding controllers action. All the routings are done in the routes.ruby file that is found in the config directory of the application. For example, the route in the line route to home #index indicates the basic route for the home page the user sees when they first launch the site, with the home controller and the index action. By following this routing convention, it is possible to set up multiple routes in one line, which makes the routing in Rails relatively easy and convenient. Rails emphasizes the software development principle known as DRY, which means don't repeat yourself. This principle is supported by using gems. A gem is a packaged Ruby application or a library. Gems allow you to easily integrate already written and tested code into your project. Therefore, you don't need to spend time writing code for methods that are already available. Gems are used to extend or modify functionalities in Ruby applications, and they are located in your project's gem file. Each gem follows this code organization structure. In the bin directory lies the executable files. This file is loaded into the user's path when the gem is installed. The lib directory contains the code for the gem, and the test directory contains tests. The rake file is an alternative to makefile that uses Ruby syntax, where any Ruby scripts can be included. The gem spec just contains information about the gem like version, author, or platform.
Some of the popular gems include Bundler, which serves as a manager for gems, Pry, which offers syntax highlighting, source code browsing, documentation browsing. It also includes the command showDoc, which can be used to show documentation for any given method. There's also a gem Paperclips, which offers easy file attachment. And finally, Ahoy, a gem used to track visits and events on your application, which is useful for analytics. Ruby on Rails provides several built-in security features, such as encrypting cookies by default to store session data. Therefore, the client cannot read or edit contents of the cookie without breaking encryption. Rails also offers countermeasurements for CSRF by introducing a required security token that your site knows but is not known by the other site. The security token is included in a request and is verified on the server. This is done automatically in the configuration file, which is default for newly created applications. If the security token doesn't match what is expected, an exception will be thrown. Rails also provides countermeasurements to SQL injections by providing a built-in filter that escapes null characters and line breaks. The filter is applied when using commands, and as a result, SQL injection is hardly a problem in most Rails applications. Ruby on Rails framework also helps protect you against cross-site scripting. To prevent XSS attacks, Rails automatically escapes all data sent from Rails to HTML output. You just need to avoid passing user input when you're not supposed to. Testing and debugging in Rails is also easy with its own built-in framework and tools. Testing is easy since the testing environment is automatically built when you first create a new project, located in the test directory. When you generate a new controller or model, Rails will also generate the accompanying test files as well. Rails has many tools at its disposal for testing, such as assertion, which makes it easy to do unit tests, system tests, integration tests, controller model tests, and more. For debugging, there are also built-in tools to help debug applications. Rails provides helper methods such as debug or inspect, and also a logger which will log information in the file's runtime.
One of the best advantages of using Ruby on Rails is that it's convenient, which enables fast development, leading to maximizing productivity. It only requires a few lines of code to build the web application, and this minimizes the amount of code the developers need to write. Rails frameworks is also relatively easy to learn, especially for first-time Rails developers. Because it uses a syntax similar to English, it's easy for developers to structure their thoughts and write the code. Another advantage is that there are a lot of helpful tools and libraries supported. In Ruby, various open-source libraries called gems are available. Gems offer numerous functionalities that are already created, and all developers are free to use the modules by simply installing them. Security is also a great strength. Rails provides a number of built-in mechanisms that cut down the vulnerabilities of cyber attacks, such as cross-site scripting or SQL injection. The most frequent argument against Rails is that it has slow runtime performances compared to other similar web frameworks. This could be an issue that must be additionally handled when it comes to building a massive project with huge traffic. Rails is also known for its slow boot speed for massive projects. The boot time of Rails relies heavily on the size of the files and the number of gem dependencies, which means that it takes longer time for huge projects to load. This may reduce developer performance. Another disadvantage of Rails is that wrong design decisions have big costs. Rails' use of Active Record as an ORM tightly couples the application components with database models, and this may create further maintainability concerns when they're not taken care of. What makes it cool? There are a lot of factors that make Ruby on Rails look cool compared to other frameworks. Ruby on Rails allows the minimum value products to be developed extremely fast. The default created testing directories and skeleton test code for its associated models and controller objects make the testing in Rails very simple. Without working directly alongside the web browser, testing in Rails may also simulate the browser request to test the application's response. Its full-stack capabilities provide intuitive integration with front-end, server-side, and databases. Ruby on Rails also comes with a well-established community with continuous support and in-depth documentation that the developers are free to use. Such helpful tools and fast development make Ruby on Rails get chosen by various worldwide companies. Other interesting features. Ruby on Rails has a ton of interesting features that we didn't cover in the presentation, so here are some that we thought were interesting. Ruby Gems isn't the only package manager that can be used. Others such as NPM and Yarn are supported for the installations of necessary JavaScript dependencies. Rails projects also include Action Mailer for sending emails and creating mailer systems. More advanced features involve the internalization for localizing the application, the asset pipeline to compress the requested JavaScript or CSS assets needed to render a page, the active support for Ruby language extensions, and finally, the active storage for management of the cloud's storage services.
Now, a quick demo of some of the features we talked about in the presentations to show off Rails' capabilities. So first off, you can generate a new Rails application through the command line with a line such as this, which will set up a new app, and also I added this at the end, which will set the default stuff for Postgres. So you can add these at the end and usually set up a database like MySQL or Postgres. If you don't add this, it will just default to SQLite. Well, I'm not gonna run this because this is gonna take a minute or so. But after you run that, it'll look like something like this. As you can see, there's a lot of folders and a lot of files that Rails sets up for you. So one of the important folders is the app that holds all the controllers, models, and views. So it's nice that Rails sets all the architecture up for you already, so you don't have to worry about that. And then now let's run the Rails server, which can be done using Rails S. Go here, localhost, and now you'll see the default page, and you'll know that you set it up correctly. As you can see, Rails command line is very powerful. You can use it to easily and quickly generate stuff like a controller. So in one line, you can do Rails G generate controller, and I'll generate a book controller with the accompanying views, which is index and list. And you just run it. As you can see, Rails automatically generates all this stuff for you. You go back to the application, you can see in the controllers, it generated a new controller and the views. So in the views, you can just edit it like a regular HTML. So I'm going to say this is my new app. And also, when we ran it, it also generated some default routes. So as you can see, it's nice that Rails is able to generate routes for us. Maybe we want to replace the default page with our index. So you can write root there, then have the book controller and invoke this action, which will then display our index. Right? After that, you can just run the server again. You don't need to rerun this server all the time. You can usually just make the changes and Rails will update it without needing to rerun the server. But yeah, as you can see, we go back here, reload, and here we'll see this, which is our index we set as the root instead of the default application. And also that other root we had, book list. Go here and it'll show the other HTML page that we first set up. So another cool thing is that if you follow convention, you can do stuff like this in the routes, for example. And this will set up multiple lines or it'll set up multiple routes for users. So if we can go here, now our Rails routes. I can see there's a bunch of routes that showed up, but look over here, you can see that just in one line, it created a bunch of routes already for users. So that's pretty cool. And this is another example of convention over configuration in Rails. If you follow the conventions, you can write less code than it's needed. Again, you can generate models in Rails in a similar way. So just in one line, you can do Rails G model. I'll make a customer model with two fields, name and status. They're both strings. And when you just run this, Rails will generate all the necessary files for you. You see it's been created. So after this, you'll see it show up in models, the customer here. More importantly, in here, you'll see the migration file as that. So after you generate the model, you can run something similar to rake db migrate. And this will create a schema for you. After running that, you go back here. As you can see, schema has been modified to have customers. So after that, we can check on our database. And we see that the customers has been added to the database just from Rails, from running that one db migrate. So now we have all the stuff set up already. And that's all. Thank you for watching our presentation.
Hi, we're Group 2, and today we're going to do our presentation on Chicago Boss, a web framework that utilizes Erlang, a functional programming language. I'm John, and I have my group mates Keegan, Alden, and VJ.
So first we're going to talk about introduction to Chicago Boss, and followed by motivation, application structure, some of the benefits, and why you should use functional programming language such as Erlang, some of the interesting features, and some of the cons or why you might not want to use Chicago Boss, and end it off with a code demo. So a quick introduction to Chicago Boss. The naming was inspired from the movie Key Largo. So the author really liked this movie and thought that the Chicago gangster portrayed in it was really interesting, so he named his web framework off of it. It was an extension of a project called EarlDTL. So before Chicago Boss, it was EarlDTL, and after the creator of Chicago Boss, Evan Miller, joined in 2010, it eventually became Chicago Boss. And Chicago Boss utilizes Erlang, a functional programming language, with the intention to address the problem of slow server-side templates.
So what are the goals of Chicago Boss? Simple. To reduce the typical website's operational costs by 90%, enable more self-hosted websites to show power independence, and enable a new generation of deployable open source projects. And to simply be a framework that gets the details right. Miller had experience with many different web technologies before, all with little things that bothered him and felt like they weren't implemented in the correct way or were implemented in a less optimal way, such as slow server-side templates, cough cough Rails, which he aimed to solve using templates that compiled down to Erlang bytecode. Miller seeked to create a framework that got all the little things correct. But why Erlang? Well, why not Erlang? Erlang brings a lot to the table. It provides high availability, it's got built-in fault tolerance. The fault tolerance has a very simple philosophy behind it, specifically let it fail/crash, so there's no need to write defensive code. It also has hot code loading, making it super simple to update the app without any downtime. Creating distributed and scaled apps is easy with Erlang's lightweight processes and the easy-to-use built-in functions to help with reaching parallelism. Since Erlang is a functional programming language, we get the added benefits of high-level functions, abstractions, and concise, readable code. You ever spend an hour reading some complex loop logic, wondering which HTML programmer wrote this, only to realize it was yourself? Yeah, that's why readable code matters. Yes, I know what you're thinking. I can hear your loud and mean shouts across time and space back here when I'm recording this. The big elephant in the room. Yes, functional programming does mean recursion. But when's the last time you wrote a web app that wasn't just moving data to and from a database? Exactly. So the whole recursion thing isn't that much to worry about. And you know what? I'm just sick and tired of all you imperative programmers looking down on recursion and functional programming. Okay, there's nothing wrong with being a functional programmer. Alright, in fact, I'll have you know functional programming has over 300 confirmed kills. So why use Chicago Boss? For starters, it's got no copy memory architecture, so shared template snippets occupy the same hunk of memory across multiple requests. For example, the same block of code will be referenced to a shared piece of memory. It has non-blocking network I/O. It's got better time complexity in some functions. For example, string append in Chicago Boss runs in constant time, versus Ruby string append runs in linear time. Tests run quickly. There's no complex view caching. It's got all your typical stuff on top of this as well, and some more cool stuff that we'll get into later.
In a Chicago Boss project, there are two important parts we need to distinguish between. There is a Chicago Boss server and Chicago Boss application. A Chicago Boss project will contain a single Chicago Boss server, and that server will host one or more Chicago Boss applications. In this configuration, the Chicago Boss server will handle shared services such as database connectivity, and the applications will focus on the tasks they are designed for, only deferring to the server node when they need to make use of a shared service. This setup allows us to separate the concerns of each application in the project, allowing for us to not have to repeat code in several places throughout the project, and allows our project to stay more modular. So let's talk more about Chicago Boss applications. So there are several parts inside a Chicago Boss application which we have access to and are commonly used. We have our models, which will provide a layer of abstraction over our database using Chicago Boss's built-in object relational mapping, and allows us to perform logic that will manipulate our data. Then we have the web controllers, which are given information about an HTTP request and will decide what to do with that request. For example, which models need to be used to fulfill a request, any additional logic that needs to be applied to a certain request, and then passing the data to the correct view. A controller will consist of several different actions, which will map to functions in the controller. Then we have our web views, which will handle the rendering of our data based on what is given to it by the controller. Typically, views are built using early DTL, which is a fast, pure Erlang implementation of the Django template language. Views will typically be what is returned as a response to a request, although we can also send JSON or other content type as a response. But before this response is sent, controllers will often perform some post-processing on it, such as caching it, logging it, or transforming it in some way, such as performing some compression or adding a timestamp. So these three parts are fundamental to Chicago Boss application, and as you can probably infer from this, Chicago Boss typically uses a MVC architecture. Additionally, applications will often contain email controllers and views to be used with Chicago Boss's built-in email server, test scripts for testing the different components of our application, initialization scripts, and a route configuration file for helping with routing requests to the correct controller. So now let's talk more about the Chicago Boss server. So the Chicago Boss server is in charge of starting several services built into the Chicago Boss framework that will be used by the different applications in our project. These shared services include a URL router known as Boss Router, which will receive HTTP requests and parse them to figure out which application should handle the request and which controller and action in the application that the request should be mapped to. We have a session storage layer known as Boss Session, which will handle the storage of sessions, including removing sessions when they are expired. We have a database connection layer known as BossDB, which will handle the connections to the database that our applications will need. Then we have a database caching layer known as Boss Cache, which allows us to cache frequently queried data for increased performance. And additionally, we have a message queue known as BossMQ, a model event system known as Boss News, and an email server known as Boss Mail.
Similar to many modern frameworks, Chicago Boss utilizes the Model View Controller design pattern. The MVC pattern divides responsibilities into three components. The model acts as the representation of related sets of data. It directly manages the data, logic, and rules of the application. The view's job is to present to the user data and any actions that may be available to them. Finally, we have the controller, acting as the intermediary between the view and the model components, responding to user input and performs interactions on the data model objects. Using this pattern would improve code reusability and simplify design logic. Chicago Boss comes with many features that any experienced web developer can appreciate. For dealing with databases, Chicago Boss includes a special querying syntax and a fully integrated object relational mapper and multiple sets of database adapters. Compatible with multiple database types such as MySQL, MongoDB, and Postgres, Chicago Boss's ORM Boss Records provides a high-level abstraction upon relational databases, allowing developers to write Chicago Boss applications without needing to worry about database language syntax. The use of Boss Record alongside Chicago Boss's built-in query library, BossDB, rapidly boosts web application development, especially during the beginning of projects. So far, we've explored features of Chicago Boss that are available in most MVC frameworks. But what kind of features does Chicago Boss has that make it unique? To understand that, we need to learn more about long polling. Before the WebSocket protocol was standardized, long polling was a strategy used to update a web page where the browser issues a request and the server holds onto the request until new information becomes available. This strategy was in contrast to short polling, which was a historically preferred over long polling due to blocking processes. Generally, long polling incurs memory costs overhead. Other scripting languages such as Node and Python could implement long pollers, but requires asynchronous code which was difficult to understand and maintain. Erlang and Chicago Boss solves this dilemma. With Erlang, code appears synchronous, but under the hood, all networking is event-driven and asynchronous, making tasks like long polling much less resource-intensive. With Chicago Boss, we can write long poll handlers as we would any other handler, making them easy to read and write, no callbacks or other workarounds required. Chicago Boss utilizes integrated message queue services such as BossMQ and Boss News to implement long polling. BossMQ is a service consisting of named channels which follow a publish-subscribe architecture. With Boss News, it implements model events to database-driven server programming. Callbacks executed when there is a change to application state.
Okay, down to brass tacks. What are the cons of Chicago Boss? For starters, the lack of documentation and community support make it difficult for beginners to get into and learn. Second, compile issues with the latest version, 0.9. Chicago Boss requires the use of Erlang version 20 or version 19, and does not support version 21 and newer. This is due to the fact that Chicago Boss's models use parameterized modules, which was removed after the release of Erlang version 21. Another downside, hot code loading isn't much of a feature anymore, since everyone and their grandmother uses containers, such as Docker. And now we're going to show you a few code demos of how Chicago Boss works, and for that we're going to pass it off to Alden.
Let's quickly look at a simple booklist app demonstrating Chicago Boss's MVC architecture at work and some nifty features that come packaged with the framework. Let's start off with how the book model is defined. In the first line, you see the module name and the corresponding data columns that a book can have: ID, author, title, and year. With just these 2 lines of code, Chicago Boss does a lot of things under the hood. If we navigate to Doc, Book, we can see an automatically generated eDoc containing multiple functions tied to the module that we didn't create ourselves. In the Views directory, we create HTML templates for the book/list and book/input. You may have noticed that Chicago Boss uses the Django template language as its templating system to create reusable view components. In the book controller, we make use of Erlang's parameterized module to receive a request object. From there, we define functions strictly matching our HTML files created in the Views directory, subsequently implementing behavior for each of the corresponding routes. Hooking it all together, we are able to save, read, and view books from the database.
That's all, folks. Thank you for watching, and remember, make your next app.
Hi, this is Group 4. Today we are introducing Foundation. So what is Foundation? It is a responsive front-end framework. Foundation provides a collection of HTML, CSS, JavaScript templates, which help users designing their own websites. There are many modular plugins for users to choose. They are all quick to learn. User can avoid writing repeated code. It saves lots of time on debugging as well. Foundation supports on multiple platforms, such as computer, tablet, and mobile phones. Since Foundation is open sourced, there are many contributors around the world. They keep developing new features and frameworks for users. Here's some history of Foundation. Foundation is originally the style guide from digital product design company called Zerb. Zerb has extensive experience on web design. It provides great amounts of resources such as CSS, jQuery plugins, and many other basic elements to help their clients build websites, software, and mobile apps. In order to facilitate reusing those elements and plugins, the company decided to build a framework, which is called Foundation, to help people design more efficiently. Now, Foundation has already updated to the 6th version. There are many new feature add-ins, and they are very helpful on building websites, and they will be introduced after a few slides. Next, we will show how to install Foundation to your local computer. Foundation provides many options to install their frameworks package. User can install with Package Manager. Foundation supports on multiple package manager such as npm, Bower, and Composer. For example, user can run the following code to install Foundation using npm. The second choice is to install with Foundation CLI, which is a version without GUIs. And finally, user can also use Git to clone Foundation's repository on GitHub to set out the documentation. After the installation, the Foundation package provides 2 types of web templates for users, Basic Template and Zerp Template. For the Basic Template, it is recommended for beginner who wants to get started on Foundation. It contains pre-configured files for websites, which is including CSS setting file and starter HTML file, and even a SAS compilation tool. Differently, Zap template is for more advanced user. It includes everything in basic template, and in addition, it also provides more features such as handlebars HTML templates, JavaScript module, built-in browser sync, and image compression.
Before you use Foundation in your project, there are a few things that you may want to consider. One thing that you need to know is that Foundation is a very large and modular collection of tools. It has separate framework offerings for websites and emails, etc. If you're looking forward to solve a wide variety of front-end problems, Foundation is the way to go. In terms of flexibility, it's quite flexible. It doesn't force any particular language or style, and it gives you a lot of control over your UI. So if that's what you're looking for, use it. Just like I mentioned a second ago, Foundation gives you a lot of freedom and endless customization options. That makes it quite complex. If you're a beginner, it will take some time for you to get comfortable with it. So if your task is simple and you just want to quickly get the job done, this framework is probably not your best option out there. It also does not have the biggest community because it's not as popular as many other CSS frameworks. It does have pretty good online tutorials and there's videos and all that, but keep in mind that there will be situations that you'll get stuck and you won't easily find your answers online.
Alright, let's compare Foundation to other CSS frameworks. Let's start with the usage of Foundation compared to other frameworks. 28% of respondents to the survey report working with Foundation in the past year. Compare this number to other popular frameworks. We can see that Bootstrap is very widely used and Tailwind is fastly growing behind. The implications of this would be the quality of resources found online and the amount of documentation available. Let's compare differences between Foundation and Bootstrap. In Foundation, it is easier to customize styles of elements, while Bootstrap has more pre-styled elements. For example, Bootstrap's buttons have a lot more styling going on with them compared to Foundation's. Due to the relative popularity of Bootstrap, it is more easy to find code documentation for that. Compared to Foundation, there is less community resources relatively. Foundation is more focused on
the visual and customizability aspects of a project. Well, Bootstrap is more focused on the functionality of a project. Foundation uses a XY grid that supports multiple grid types. You could have a margin grid, a padding grid, a frame grid, while Bootstrap's grid does not support that, and Bootstrap's grid is Flexbox based. Let's cover differences between Foundation and Tailwind CSS. Foundation is a UI kit, while Tailwind is not a UI kit, meaning Tailwind does not have preset components, while Foundation does have preset components like buttons, menus, and navbars and forms and such. This could mean that there's more of a learning curve when using Tailwind CSS, because you have to make your own components while Foundation does not. Foundation is one large file, so it has a pretty large size, 133 kilobytes, while Tailwind CSS is usually around 10 kilobytes with their method of CSS purging. It really depends on how much of the utilities you use. That's the basic comparisons of Foundation with other CSS frameworks. I will turn it over for a deeper dive into Foundation itself.
So now we're going to take a look at a bunch of tools that Foundation provides to help make our lives easier. The first type of tool that we'll be taking a look at are those that help with the layout of our content, such as the XY grid, which is the default grid for Foundation. Foundation also has other grids, but the XY grid is the most current. The XY grid is inspired by the CSS grid, but it's built with Flexbox. The second type of tool that we'll be taking a look at are containers, like accordions or drop-down panes. And containers help us to organize pages or content that we may have in our website. And finally, we'll be taking a look at some plugins such as form validators that help us achieve different tasks. This isn't a exhaustive list, but it is a good baseline to demonstrate the kinds of things that Foundation can help us to do. So the first thing that we'll be taking a look at is the XY grid, which is fundamentally a 12-column Flexbox grid layout. What that means is that each row can be divided into 12 different columns at max. So in the first example here, we've divided the row into 12 separate columns. And in the second example here, we've divided it into 6 columns. So each column is twice as big as the column in the first example. So here in the second example, if we were to try and add a 7th column, that would then flow down. So the XY grid also has a very easy mechanism to use to shift your content around within the grid using various tools. So we've shown some here, margin cutters and padding cutters. So each cell is denoted using this solid black border, and the space between the cells is called the margin. And here the red area is the padding, which is the space between the cell boundary and the content. So by changing the values on both of these things, we can change how the content is located within the grid. These aren't the only ways we can do it. There are more advanced tools such as cell collapsing or responsive adjustments that can help us eventually size and position our content in the grid effectively. Next up, we'll be taking a look at containers, specifically the accordion container. So the accordion container is made up of a bunch of panels. Here in this example, there are 3 panels, and each panel can be expanded or collapsed. And each panel can contain anything you want, pretty much, like forms or text or links. And you don't need to work too hard to get this container. You just need to add a class accordion and the attribute data-accordion to the container. And then to each of the panes, you can add a similar class and attribute declaration. So the next thing we'll be taking a look at are drop-down panes. So drop-down panes can provide smaller amounts of additional content like text or forms. They can be customized
to be a bunch of things. So here there are two examples, a toggle dropdown and a hoverable dropdown. So the toggle dropdown activates when it's clicked, and the hoverable dropdown activates when your cursor hovers over it, and you can include things like forms or text in them.
Foundation offers some pretty cool plugins, and I'm going to go through two of them today. The first one is Abide, which is a form validation library. It's basically an extension to the HTML validation API with some custom validators. As you can see here, it forces the user to fill the required fields and use the right formatting. As you can see down here, it offers so many different patterns and validators. And all of these built-in validators are actually just regular expressions. You can create your own custom patterns, or you can override the built-in ones that already exist, again, by using regular expressions, or you can actually just create your own custom validator function too. Another thing to keep in mind is that you're going to need to add data abide in your form tag to let the browser know that you're using abide. Also, you will need no validate too, because otherwise your HTML browser validation can interfere with your abide validation, which will create some complications that you probably don't want. The second plugin that I'm going to talk about is Equalizer. Equalizer is a library that makes it very simple for you to give multiple items equal height. For example, you may want to have 3 columns that have the same height. So how do you do that? This is actually also an example of where you would want to use a container, because to set up an equalizer group, you're going to need a container, and you're going to need to set its attribute to data equalizer, and then give it a series of children. And every child within this container is going to have the same height. Also, the element that has the highest height in the container will determine the unified height of all of the children.
Next, I'll show you some code and practical demonstrations which can better and more intuitively understanding the meaning of the foundation. The first things that we can see here is the 12-column grid mentioned by my team member before. There is something that we need to pay attention to is the size of the web page will always remain at 12 columns. One of the reasons that we choose the foundation is that the foundation is more unique and can customize a site that looks different from another site. For example, if we want a table, we can see from the code here that there is a completely default setting. The default element style of the foundation table tag is the gray zebra strips that contains the borders, which looks more layered. The following I show some basic button groups. So there are some the different color of the buttons. There are some the different size of the buttons, different functions of the buttons. This is called the drop-down buttons. We can choose each options and jump directly to the page. Foundation not only have the advanced and complex interface, but also provides the responsive menu and the compatibility with the various devices and browsers. Let's first look at the visibility of the foundation. This text element will change as the window size change, show and hide. So right now we are in the large screen size, and now we are in the medium screen size, and we are shrink. We are in the small size of the screen. These are done by the class called show for something, instead of using the visible and the invisible tag. So we can only just use this class and show the demonstration. In general, designers need to consider how to re-layout element on the different screen size, but Foundation provides visibility options which can have more interesting operabilities on large devices. For the display problems of the different devices, Foundation also provides a very flexible design. So let's go back to the home page and go to the responsive page. Designer can follow the design the set yourself approach to the greater control over the project.
Dragging to change the size of the windows will change the element layout. So let's see the code here. The display here is large 3, means each div block will occupy 3 positions on the large screen. And we have totally 12 column layout, so which means one line, one row can fill all the stuff. But what about if I want to change the layout? What about if I'm in the medium size of the screen or small size of the screen, I want to change something? So maybe I can see, I can write the mediums. So right now what I'm writing is the medium size 6. So these two 6 plus together is the 12, so which means the one row can contain 2 divs. So it totally is only have 2 rows. And what about the small side? I can say the 5 and 7. So there is a ratio like 5 to 7. So totally is 12 in the one lines. And I save it and refresh the page, and then you can see the final demonstration here. So what I'm saying here is that if I not mention about the small size page, it will remain into the default setting. So the default setting is the one row, one line contains one div. And the same thing that I apply to the buttons and the pictures. So the foundation is more unique, flexible, mobile-friendly language. Because of it has a built-in basic CSS appearance, it can save so many code lines.
So in conclusion, Foundation is a great tool that can help users in many aspects. It is recommended for both beginner and advanced users. It is easy and quick to learn. It will be documentation and community forums on Foundation websites, which guide users to get started on the tool. The Foundation framework is also highly customizable. It provides a modular tool to allow users implement only the parts of Foundation that users need. Foundation also has a faster core that improves the performance on websites and saves users a lot of time waiting for animation and transitions. Here are references that we use in the presentation. And thank you for watching.
Hello all, and welcome to our talk on the Phoenix framework. Today I'm going to go over some of the higher level concepts and key features of Phoenix, and then I'm going to toss it over to a couple of my group members who will walk you through a quick demo. So before we get into the specifics of Phoenix as a framework, I'll explain a little bit about Elixir, the language in which Phoenix is written. Then I'll talk about the Beam virtual machine and how it handles concurrency, and then we'll get into the nitty-gritty of Phoenix itself. So, Elixir is a programming language built off of Erlang, a language commonly used in telecoms. It was created by José Valim, a Ruby developer who wanted to create something with native support for concurrency. Elixir is functional, though it is also stateful, unlike many pure functional languages, meaning it can store variables. It runs on the Beam virtual machine, which allows it to achieve high levels of concurrency and throughput while being fault-tolerant, which we'll get to in a second. Elixir is still a fairly niche language, but its popularity is growing, and some fairly prolific companies like Discord, or if you've ever taken an IT co-op, PagerDuty, use it in their software. So I've mentioned Beam a few times, but what is it? Well, Bogdan's Erlang abstract machine is a virtual machine for running Erlang code. What makes Beam special is that every piece of code is run in a process, which is like a very lightweight thread. Note, though, that Beam processes are not the same as OS processes or threads. The processes are handled by multiple schedulers running on the different CPU cores of the host machine. Each process is handled completely separately, and they communicate with each other if they need to via message passing. The advantage of handling each process separately is that if one process crashes, the others can continue without issue, and only processes that need to know will be notified of the error. This here is a demonstration by Sasha Jurich, linked at the end of the slides. As you can see, thousands of Beam threads can be run at once with very little cost in terms of memory and startup time. The number here probably isn't exactly 33, since we don't know what else is running on its machine, but in any case, it's very low, less than 100 megabytes for 10,000 processes. Beam processes can also be distributed across many different servers, as any scheduler in the virtual machine can take on any process. So because of this, programs written on the Beam virtual machine scale very well, making it ideal for telecoms or web applications. Beam's native support for concurrency and high throughput is very important to the Phoenix framework. So now let's actually talk a bit about Phoenix. Like a lot of other technologies we've seen over the past couple of weeks, Phoenix uses an MVC model. So the user's actions are handled by a controller, which makes some changes to a model, which in turn changes the view, which is what the user sees. Now, the way a typical SPA or single-page app works is that there's a program running on the client side and a program running on the server. And each time the user does something, the client sends a request to the server for some data, usually JSON or something similar, which the server sends, and then the program running on the client side processes the data and updates the view. The client and server here are fairly separate. They could be running on different languages or completely different frameworks, which adds a bit more work for the developer in terms of managing the system. Phoenix, on the other hand, uses something called Live View. Now, Live View can look like an SPA to the end user, but the underlying code is fairly different. With Live View, there's actually very little code on the client side. Pretty well all of the logic of the system is handled by the server. Each session uses a persistent WebSocket connection, each running on a separate Beam process. This allows tens of thousands of concurrent sessions at once. When the user makes some change on the web page, the event handler just sends the event back to the server, which processes it, updates the model, and sends back only what needs to change in the current view, rather than re-rendering the whole page. So the client-side code just applies the change. Maybe that was a lot of information, so let's look at an example. Here we imagine a web page that has a counter of some sort. The user clicks to increment the counter. You can see here that this small addition to an HTML tag is all that's needed for the Phoenix framework to send the increment event back to the server. The server then finds the appropriate event handler, which updates the value in the HTML, and then the server sends back just the HTML that got changed, which the client renders. Nice and simple. So why choose Phoenix? Well, traditionally you have a choice between MPAs and SPAs. Multi-page apps, or MPAs, tend to offer a less dynamic and responsive feeling web app, but are generally quite simple to make. Single-page apps allow for a much richer user experience, but also have a lot more complexity when it comes to building and maintaining them, as is illustrated by this rather non-specific bar graph. Then we have Phoenix Live View, which offers a great deal of responsiveness and flexibility while not being very complicated. Connections run over Phoenix can update incredibly quickly. There have been examples of people actually making very basic games that work responsively enough to be playable using Phoenix Live View. And you'll see in our demo that setting up a Phoenix app can be done so quickly it kind of feels like cheating. Phoenix will generate a lot of the required code for you just from simple command line instructions. However, much like everything ever created, or citation needed on that, I guess, there are pros and cons to Phoenix. For instance, you should not use Phoenix if you need your web app to be usable offline, as all of the page's functionality relies on having a persistent WebSocket connection. No internet, no app. It's also based on a much less well-known language with a smaller ecosystem. Elixir is a functional programming language, which is a paradigm a lot of programmers aren't terribly familiar with. If you want to learn more, take 383. And the syntax is quite different from more commonly used languages like Python or Java or C. As a result, there's less community support for it. The number of Stack Overflow questions is a very useful metric for how popular a given language is, though I'm sure by the time you're watching this, these numbers are already out of date. Another reason you may not want to use Phoenix is if for whatever reason you don't want to use an MVC pattern for your app, in which case you'll be fighting against the framework to get it to do what you want when really you could just use something else. So that's Phoenix. The demo video earlier was from Sasha Urich's talk, I hope I'm saying that name right, on Elixir, which if you're interested in learning more about Elixir and Beam, I highly recommend. And now, over to the demo.
Avery will now demonstrate how easy it is to use Phoenix. Note that he has installed the dependencies beforehand. First, he runs the mix.phx.new command, which bootstraps the Phoenix application from the Phoenix demo directory. Phoenix generates the directory structure and all the files we will need for our application. Avery now changes into the created directory and uses the mix.ecto.setup command to initialize the Postgres database. He has prepared a custom CSS file, so now he's copying the custom file into the app's CSS directory. He then changes the app's CSS file to import his custom file. Running mix.phx.server then starts the server, and you can see that the Phoenix homepage loads successfully. mix.phx.gen.auth account user users installs the authentication system, creating templates, views, controllers, as well as a new context. mix.deps.get installs all new dependencies, and mix.ecto.migrate applies database changes. Avery starts the server again, and you can see the new register and login buttons. Clicking register brings us to a register page. Avery adds an email and password before registering. We can see that a user has been successfully created. Going to settings allows us to change our email and our password. Finally, we can log out and return to the home page. Now we want to make it so only authenticated users can access our page. We load up our router and change our plugs to require authenticated users. Restarting the server and refreshing the page shows that we're not authorized to view the home page. Logging in lets us access the home page. We're now going to add chat messages to our page. Running mix.phx.gen.live chat messages content string generates live view, templates, and context for the chat context module. The second argument, message, creates a schema module, responsible for mapping the database fields into an Elixir struct. The remaining two arguments are the schema module plural name, messages, and the attribute content, which is of type string. Avery then applies the database changes. Opening the router again, he adds the two new live routes messages and messages new so that the pre-built message live index page can be served directly from the router through the messages and messages new route. Opening page controller, instead of rendering the index.html, Avery redirects from the connection to routers.message index path. Loading up the message live index.html file, Avery then removes the redundant routing logic. Booting up the server again, we can see that we're redirected to the listing messages page, and as you can see, our new message is added to the content section of the page. Avery is now demonstrating the use of Phoenix channels that enables real-time communication between connected clients. Channels are pretty simple. Clients connect to the server, and once they're connected, they join one or more topics. Clients can then send and receive messages live to and from the topics they've joined. Servers can broadcast messages to all clients subscribed to a certain topic. Avery first creates a topic. He then defines a way for clients to subscribe to a topic. Broadcast change is created to broadcast new messages to all clients subscribed to the topic created earlier. By piping all created messages to broadcast change, Avery ensures that all new messages created are received live by clients subscribed to the topic. Avery then opens up the message live index file. By adding subscribe to the mount call, clients are automatically subscribed to the topic when joining. The newly created handle info call adds the received message to the content section. Now Avery starts the server again, and you can see that messages sent from either windows appears almost instantly on the other window. Now Avery is going to limit the number of messages in the content section. Avery opens up the chat.ex model and adds a new function called list recent messages. This function filters the number of messages to 5, and by piping it to enum.reverse, the order of messages can be reversed. Opening up the message live index page, Avery changes list messages to use list recent messages instead. Now Avery is going to launch the server again and post some messages. We can see that the number of messages is restricted to 5. Avery is now going to create a very simple messaging app. First, he opens the index.html.heex file and pastes some code that he wrote beforehand. The title is now live chat. He has added a seconds ago field, and the live actions have been modified to update the page live. He then goes to the form component, which is what is being submitted as a post. He removes the title, the label, and modifies the submission button to state post instead of save. Finally, he navigates to the message.mx file, adding a validate length pipe to the message, ensuring that the content has a max length of 140 characters. Launching the server, we can now see that we have a pretty nice UI. And loading up another page, we can see that the messages still update in real time.